Welcome back, and today we are talking about slope, and slope is the rate of change between 2 points on a line. Now, if we were to represent that using a formula, it would look something like this. Slope equals change in y over change in x. And you may have heard this. So you got to understand slope is usually represented by the variable m. You might ask, why is it m? I was always taught that we don't use an s for slope because s looks kind of like a 5, which is true. Anyway, m is slope. I don't know why we picked the variable m for slope, but again, I'll tell you what, m doesn't look like a 5. Anyway, so slope equals rise over run. Why do we use rise and run? Because rise is your up-down movement, while run is your left-right movement. Okay. Speaking of running, I usually run to the right on my slope. Okay. Usually to the right. That's my pattern. It makes things easier for me. At least I find it easier. So, how does this look? Wheel. Let's find the slope of a line right here. Try to squeeze it all in. We're going to do a little graph like this. And we'll just label this guy. Probably do the best we can. And if we wanted to find the slope of a line, the graph's going to give you some information here. So there will be something like this. Let's see if I can do a nice straight line, guys. Look at that. Not a bad line. Anyway, boom. So there is our line, and you're usually going to have some nice dots on them to work with. Okay. So if we want to find the slope of this line, we do pretty much the same 2 steps all the time. Step 1, I like to start from the leftmost point and find the rise. Start from the left point. And find the rise. How does this look? We would go from this dot right here, the leftmost point, and we're going to find the rise. 1, 2, 3. We pretty much have to go up until we are at the same level as that particular dot. So we need to rise up or down. And again, if we're going up, that's going to be a positive 3. If we'd be going down, it'd be a negative 3. So we have a positive 3. That's our rise right there. And now we have to sneak over to the actual dot. So step 2 is then find the run. Remember, the run is the left-right movement. So I'm going to hop 1, 2. That'd be my run right there, guys. Usually these guys are going to be fractions. Not always, but usually. Okay. So now I just kind of put this together. My slope equals rise over run. What is the rise and run? Well, the rise is 3, the run is 2. You want to leave this as a fraction unless you can reduce it to a whole number. You wouldn't want to put 1.5 there for slope. Okay. And remember, if you're going downward when you look for your rise, that's a negative. Those are negatives down there. And if you go left, if you ever have to go left, that's a negative movement as well. All right. Now, the other thing about slope you're going to see is you're going to be given 2 points sometimes. Okay. So how do we do that? Finding slope when given 2 points. This guy uses a formula, okay? And the slope is y2 minus y1 over x2 minus x1, okay? Where x1 and y1 are your first point, and your x2, y2 are your second point, okay? These little numbers down here, little twos and little ones, you're not multiplying those. They're not exponents. It's just x1 is just your first x coordinate. x2 is your second x coordinate, okay? So let's do an example. If we're given a little problem, this is my example. Given 2 points, 4 and 20, and 7 and 14. Find the slope. Okay, remember, m is our slope. So all we do is we are going to use that formula. Slope equals y2 minus y1 over x2 minus x1. Now, personally, I like to label my points x1, y1, x2, y2. I find that helps my brain because now when I'm substituting values into my formula, I know exactly where they come from. So my y2 is right here. So 14 is going to go right there. 14 is going to be first. And y1 is 20. And then that's over x2, which is 7. And x1, which is 4. Okay. Well, you do have to be aware of double negatives. You will see double negatives a lot on slope. Something like, 8 minus -6. Be aware of that. And then we just solve this guy, like the top part. Then in the numerator, we have 14 minus 20. That's -6. And in the bottom, we have 7 minus 4. That is 3. So the denominator is 3. Now, this is one where we can reduce pretty smoothly. -6 over 3 will be -2 for our slope. Okay? Boom. There we go. Now, I want to talk about 2 special cases you might see. These guys are common. I should say uncommon. I mean, you're gonna run into them. But what if you have a line that goes straight up and down? How do we do that? That's not even straight up and down. Let me try again. Straight up and down line. What's that going to be? Or straight left right line. What's that going to be? I'm not going to lie, guys. I don't know why this thing is not going straight up and down. Third time's the charm, or we're not doing it. You know what? That looks decently straight up and down. I think we're going to call that good. Anyway, straight up and down lines and horizontal lines are different. Now, does this line right here have rise? Yes, it goes up and down, but does it have any run? If it was straight up and down, it wouldn't have any run. So if we were to write it using the slope information, remember slope is rise over run, this has some rise, but it doesn't have any run. We cannot have 0 in the denominator. So this guy's slope, this line's slope, would be called undefined. Why is that? Because it has some rise, but it doesn't have any run, and you can't have a 0 in the denominator. So a vertical line has an undefined slope. Now this guy over here on the right, it has no rise, but it has some run. Well, how would we represent that as a fraction? We'd have rise over run. It has no rise over some run. Well, 0 over anything is just 0. So I'd write m equals 0. Boom. With this fraction on the right, we have to remember, oh, 0 over anything is 0. That's a legal fraction. We can still get a number out of that. It's a 0. Anyway, so again, you've got your left-right line is a slope of 0, and an up-down line is undefined. One way to remember it is if you were sledding, this would be 0 fun because you're not going anywhere. And if you went sledding down a hill like this, you won't remember it because you'll probably get injured and have a concussion, and that'll be undefined. Anyway, there you go. Thanks for watching.